So friends, you must have watched my video number 1 and 2 for building the RESTful Java web service. In continuation to these two videos, as part of the video series for building RESTful Java web service, today I am going to show you how to handle query parameters of URI by implementing Java method in RESTful Java web service class. So this is the third video and I call it as step 3 for building RESTful Java web service. So let's understand one thing. If you remember, we had talked about student entity. In the earlier two videos, we have built our RESTful Java web service for 4 resources. One of the resource is student. So we had a student table in MySQL database. For the student table, we had created an entity class by using NetBeans IDE, right? So in video 2, I had shown you how to create the entity class from the database. So for the student table, we had a student entity class. And then we had built the RESTful Java web service for the student entity class. So the student faculty REST Java class was created. So for the student resource, we had an entity class. So I'll show you. We had an entity class. And we also have, so if you can see here in the left panel, we have the student.java, the entity class, and student faculty REST.java, our student RESTful web service class. So these two classes we are going to work with today, right? So in the earlier two videos, we had created a Java web application, and we had created our RESTful web service. So first we created our entity class student.java, and then we had created our RESTful Java web service student faculty REST.java. So these two classes were created for our student resource. Uh, Coming back now, in continuation to this, what we are going to do is our student resource class was able to handle. Okay, let me show you. Okay, I'll go to the student faculty REST class. If you remember, the student faculty REST class had 4 methods: the public void create, the edit, the remove, and the find, which allows you to do CRUD operations on your student resource. That is to create the resource, read the resource, update the resource, or delete the resource. Now today, what we are going to do is we want our REST clients to access the student resource by querying for the student resource by its first name and the last name. In the earlier videos, we had only created the RESTful Java web service class with the Java methods which were allowing operations on the student resource by its ID, the identifier. But now we want to allow the RESTful web service client applications to access our student resource by invoking the student RESTful Java web service. But in this case, the client should be able to access the student resource by its first name and last name. So very simple, we need to add a new URI part template, and we need to give it to our REST clients that you can also call this URI, right? And we expose our student resource via first name and last name also. So you can query the student resource by sending a URI which has query parameters first name and last name. So in short, we wanted to handle this new URI part template. So the first step is we'll write the URI part template. Let's see. The first is the HTTP protocol. The first component of the URI is the HTTP protocol. Then localhost colon 8080 means the server host location. It means this is the location where the RESTful Java Web Service has been deployed, or this is the location where the RESTful Java Web Service is running. Thereafter, we have NS University Web App. It means this is the context host, the application, the name of our application. You know, the web server or the application server can have several applications deployed. So this name is required in the URI. This name represents the application name. We sometimes call it as a context root. And then the relative URI path is the resource name, the resource type. Correct? It means we are invoking the student resource. So, and then finally, we have the last URI path called query slash search by slash name. So after this path, we have a question mark, and what follows the question mark is the query parameters. Because now the REST clients are going to invoke the student resource by its first name and last name. So the value for these parameters has to be passed. Correct? So we are creating the part template so it doesn't have the values. This is just a template. So we will replace the values with the variable names. So it means our query parameter name. Our query parameter is a key and a value pair. So the first query parameter name is first name equal to its value semicolon, then semicolon, and then the second query parameter tuple where last name is the key equal to last name value. So it means after the question mark we have two query parameters. This is our uniform resource identifier, and we call this as the URI part template. This URI part template is normally exposed to the clients or to the outside world. The clients in the outside world can access the RESTful web service, right, by using this URI. So they are going to send this URI. They are going to send that get or post or delete HTTP requests to this URI. Whenever the REST client wants to access the student resource by its first name and last name, then the client is going to use this URI, and it will send its HTTP request message to this URI by using this URI. Correct? Let's now take a particular scenario. The REST client wants to access or read the student resource where the student is having the first name as Sunny and the last name is Parik. It means this is a substituted URI where the first name and the last name query parameters are substituted with values. Now, as we want to read the student resource, normally the client will send a get HTTP request. Correct? So now our URI part template, we understood the URI part template is ready. It can be given to the client, right? But when the client sends request to the RESTful web service, right? We know that normally the client will send a get HTTP request to the URI. So by looking at the URI, we can see that the request will reach the server, correct? Because the host is specified, host name is specified. It will reach the application because the application name is specified. And then we have the resource name, which is specified. This resource name links to the RESTful web service client. Sorry, it links to the RESTful web service class, the Java class. So I'm going to show you. We have the student fact rest, which is the RESTful web service Java class. If you can see here, public class student fact rest is decorated by two JAX-RS annotations, @stateless and @path. This @path has one parameter, and its value is the URI relative URI path. If you can see, this is nothing but the resource name, the resource type, right? So it means the resource type is linked to this RESTful Java Web Service class. Very simple. So if you see, whenever the JAX-RS runtime will find this resource name or the resource type, it will try to find the matching class. And you can see here, the class is linked to this relative URI path, the resource type. That's why we are using @path notation to link the resource type to the RESTful Java Web Service class. So the JAX-RS runtime would be able to resolve resolve the RESTful web service class name. Then now the class can have number of Java methods, right? We have create, we have edit, we have remove. Remove is handling the @delete HTTP method, and edit is linked to @put method, and create is linked to @post method. Similarly, find is linked to @get method. So the point is, how can we link this request? It means this URI, how can we link it to a particular Java method? That is why we have the remaining path for. We can use this path, and we are going to add our Java method and link this relative URI path to our Java method. So let's copy query @search by /name, and this we are going to link with our Java method by using @path and notation, right? So let's start writing our Java method. Friends, now before I show you, let me explain you that before we write our Java method, we have to do two things. The first is we have to open the student entity class, and remember, our student entity class has the knowledge of the student table. It means for one entity class, that each entity class is linked to the table, at least one table. So student entity class is linked to student table. Where is that mapping? The mapping has been shown here. This is my public class student entity class, and @entity, @table. These are the two annotations used to link my student class to the table, database table named student. So what does this notation say? Annotation says @entity means this class is an entity class. @table, and it has a named element. Name is equal to student. This is the database table name. It says that this entity class is linked to this table. Also, it has several named queries. And what we are going to do is, it has several named queries. These named queries are going to be used by the entity manager in order to manage the life cycle of this entity. So whenever entity has to be fetched from the database table, some of these queries may be used, correct? So now the first thing is, we are allowing clients to access our student resource by querying it by its first name and last name. right? So it means we need to add a new named query. Let's see in the student class, do we have a query which allows you to find the student resource by his first and last name? No, first one here, this is the query name find all, find by student ID, by last name, mobile and first name. So we don't have any named query which allows you to find the student instance from the database by its first name or last name. So the first step is to add the named query in the student entity class, student.java. So within this named queries box and within this curly braces, after this last declaration of the named query and notation, put a comma, copy this last named query and paste it after the comma. Now we have added our own named query and notation, and a named query and notation has two parameters. One is called as name and the other parameter is called query. It means it has two named elements, name and query. The first named element, every element is a key and value pair. So the first we give name is equal to our query name. Student is the class name dot find by, I'm going to find by the name. It means first and last name. So I'll give this query name find by name. Then I have to give the query. Second parameter or the second argument is query. Query is equal to what? We have to mention the select statement here. Now this select statement is written in Java persistent query language and it looks very similar to the structured query language. Now if you want to like to deep dive and know a little bit more about Java persistent query language, I have provided additional learning resources, web links on Blackboard in the content folder. Please go and refer from there, right? So friends, here this is select S from student class, and S is the alias for the student instance, where S dot first name is a attribute of student class, and that attribute is linked to the column first name in the database table, right? We know that this first name attribute, it is a variable of the student class, but this variable is linked to the first name column of our database table named student. So now is equal to, I'm giving the parameter name. Always parameter variables are declared by writing colon first name. So this is my parameter first name. But I still need to write the AND operator, and s dot last name is equal to, I have to specify the parameter. These parameter values would be substituted by the actual values at runtime, correct? So we wrote our named query. It has two parameters. It has two parameters at colon first name and colon last name, correct? These parameters will be substituted by its values when this query is going to be called at runtime. So after adding a named query in our student class, 50% of our work is done. Then we go to the student facade rest, and in this class, if you remember, I just told you whenever the HTTP GET request is received by our server and when the checks are as runtime processes the remaining URI, it's this part, because the previous part was already processed, because the guest by processing the previous part, the HTTP GET request was delivered to our server and to our application, and now the remaining relative URI path will be processed. So let's look at this. This is the resource name and type which will allow it to map to our RESTful web service class. We can see student facade rest is linked to the relative URI path, and the name is edu.nsuni.entity.student. At the rate path annotation, the checks rs annotation allows to link this relative URI path to the RESTful web service class. So now at least that we know the request has to be forwarded. XRS runtime will know that the request get HTTP request has to be forwarded to this class. This class has the operation which will satisfy the client request. So now let's go back. We found the class, and the remaining URI path would be linked to the Java method, which has a Java method which will actually handle this URI. Correct? So we are going to copy this, and now we are going to write our Java method. So now we are going to add our own Java method. I have already written it, but I'll show it to you. As we are handling the HTTP GET request, if you see, we have written the URI path template to handle @GET request. So I'll write @GET annotation. Thereafter, I have to write @path annotation, and I'll paste that copied path here. Control V. It means now this path is going to be linked to our method, our user-defined Java method. Correct? So we understood that part, and this Java method is going to produce student resource representation in two formats, XML and JSON. That is why @produce annotation is used, and this annotation has one parameter, and this element is passed as a parameter to it, is an unnamed element which has a list of values. First value is application/XML, comma, second value is XML application/JSON. So this Java method can produce resource representation in XML and JSON format. So it supports these two formats only. Later on, now I will actually write my Java method. Public is my access modifier. It means this method can be called by JAX-RS runtime. And my method name is find by name. These names should exactly match with the named query which we just wrote in the student entity class. So we normally copy it and we'll paste it here. Right? Now my method is going to return. So this is the return type. It will return what? See, whenever the client is going to find by name the first name and last name, it can happen that two students can have the same first name and last name. So the RESTful web service may return multiple resources. It means multiple student resources, because two students can have same first name and last name. That is why our Java method is going to return a list of objects. So what is the type, the class type for the object? It is student. This is the entity class name. It should be same as the entity class name. So within angular bracket, we write the entity class name student. So this list which would be returned would be list of student objects. And then within this round braces, we specify our method parameters. Because find by name, it means ultimately in this Java method, we are going to call our named query. Right? And we are going to tell the entity manager, execute this query and fetch the student resources from the database and do the needful. So that is why we need those two parameters. Correct? Which two parameters? The named query, my named query in student.java class has two parameters. This first name and last name. That is why, coming back to student packet REST class, coming back to our method find by name, we'll have first method parameter is string first name, and the first method parameter string first name is decorated. So this is the method parameter, is decorated with @query param annotation, which takes one parameter, and this parameter is my query parameter name. which is given in my URI path template. The same name has to be copied and placed here, first name. So I have linked now the query parameter to the method parameter, right? Similarly, I have second method parameter string last name, and I will decorate it with @query parameter, and this query parameter and notation has one argument here, last name, which is enclosed inside double quotes. This is the query parameter name, which is given in our URI path, correct? So that would be copied here. So we are set, our method definition is already given, and now we have to write the body within curly braces. We are only going to do what? We are just going to create that named query, which we are written in student.entity class, correct? And we are going to set the parameters for that named query, and we are going to execute that query. Simple. So we know that entity manager, I had explained in my classroom that entity manager normally will manage entity managers will entity managers will normally manage the life cycle of our entities. That is why if you want to create a name query, right, and you want to fetch the student resources by calling that named query, you are going to use the entity manager object. EM is our entity manager object here, and we write EM dot. As soon as you type dot, it will show you the list of queries we can call create named query, which has two arguments. Call this method create named query, which has two arguments. That is what I have done here. The first argument is going to be our query, our named query name. This is the same name which we have given in student.java. Just copy it exactly. And so the named query is always given in enclosed within double quotes. And the second argument here is the class name which has this named query. So we know that our class where the student.java class has this named query. So the second argument which we will be passing is student.class. Don't enclose it within double quotes, right? And don't write here student.java, it would be student.class. Now after calling create.named query, we have to, it will return you a named query object, and we are calling then dot the set parameter method of named query, correct? So because our named query requires two parameters, first name and last name, so we have to pass the values for both the parameters. That is what we are doing. Dot set parameters allows you to pass the value for the parameters, that both the parameters. So first call dot set parameter, and for first argument is my named query parameter name, first name. It should be exactly the same as we have given in our student entity class in named query. You remember in this named query we had given this parameter name after column first name. Exactly this should be provided here with enclosed within double quotes. Dot set parameter, give the parameter name, comma, first name. What is this first name? First name is this method parameter. So my query parameter of the URI is linked with the method parameter, and this method parameter I am passing to the named query, correct? It means the value would be passed here, right? I am then setting the next parameter, dot set parameter, last name, that is my parameter name enclosed within double quotes. Second argument is last name, that is my method parameter variable. And then I'm finally going to say my query is set get the result list, because my query is going to return me a list of objects. That is why I'm saying dot, I have two options. Either I can get parameter, I can get single result. Whenever my query returns a single student object, I should call get single result. And if it returns me more than one student objects, then I have to call get result list. And then terminate my statement, semicolon terminates Java statements. So I terminated this Java statements. But get result list is return me and is going to return me list of student objects. That is why I have to just append the word return in front of this create named query statement. So write return, it means list of student object would be returned. And then I close the curly braces, my Java method is completely written. This will handle my new URI path template. So whenever the REST clients will send HTTP GET request, right, by using this particular URI, which I just showed you, correct? In this particular case, this Java method which we wrote, this new Java method which we wrote inside our student facade REST class, our RESTful Java web service class for the student resource, this method would be called from student facade REST class. And thereafter, what does the entity manager do? Because we gave the name query to entity manager and we say call it. We pass the query parameters to the method. Inside the method, we are passing the parameter to the query, and the named query is given to entity manager. So entity manager is finally going to fetch the student resources, which has the first name as, in our case, Sunny, and the last name is Parik. And then finally, the student instances will be created, and JEX RS runtime will convert that student entity instances, suppose only one student instance is found, but that instance would be converted into a resource representation in XML or JSON format as per the client's desire. And then finally, the resource would be sent back to the resource representation would be enclosed in HTTP response, and the response would be sent back to the client. So in a nutshell, that's how it happens. So we completely wrote our Java implementation, save it, build it, right click upon your project and select build, clean and build, go to this output window and see the build process result. If it says it is built successfully, you are ready to go, you are done. Yes, it is built successfully. Now right click upon your project and deploy it, and if it deploys successfully, then it means now you are ready to test your RESTful web service client. So we know that we are not going to write again a client application in either .NET or PHP or say JavaScript. We will just temporarily create a test RESTful web service client. So it means you right click on your project, right click and select test RESTful web service. It will ask you that it is going to configure a REST test client. Click OK, and our application was deployed successfully on GlassFish Server 4.1. Now it has created another demo client application. It's a web application, and it's going to call our RESTful web services. So it shows here student, expand it, and the first option, this URI query search by name, is our URI which we just created, the new URI path. And then it asks you that would you like to send now this is the client, so it's going to specify, would you like the content types will be application XML or application JSON. We'll select XML first, and then we'll pass the Sunny and the first name and last name query parameters. These are not path parameters, it is query parameters. And then we click upon test, and it shows you the student resource in XML. Client gets the student resource in XML format from the RESTful Java web service, and you can browse, click upon the header tab, and you can see the content type was application XML. This is the HTTP headers. That's all, folks. I think I showed you this example of how to create your own URI path template, and then how to write a Java method which will handle that URI path template, which will handle requests for that particular URI. So it means we have completed the exercise where we have we will be able to now handle query parameters of URI of a new URI path template by implementing Java method in RESTful Java Web Service class. Simple, practice it, and if you have any questions, just post your questions on the YouTube channel. Thank you guys.